All right, team, let's start with a simple question. If I told you your Wi-Fi password was 1234 password, how safe would you feel? Probably not safe at all, right? That's because security isn't about whether you have a password. It's about how strong, layered, and thought out that password and your whole system really is. So picture this. Your network is a castle. You want friends to come in, but you don't want dragons, thieves, or nosy neighbors sneaking in. The problem? The more locks and guards you add, the less convenient life gets. Imagine locking your fridge every time you want a juice. That's why in IT we always say, security and convenience are enemies. More of one usually means less of the other security definition. From Latin securitas equals free from care. But in reality, we never hit 100% security. Instead, we aim to reduce risk, detect attacks, and recover fast. CIA triad, confidentiality, only the right people see info. Example, your credit card info stays private, achieved with encryption, passwords, physical locks. Integrity, data stays accurate. Example, hackers shouldn't change pay $100 to pay $1. Tools, checksums, digital signatures. Availability, systems must work when needed. Example, Netflix shouldn't go down right before the FIFA final. Tools, redundancy, backups. Layers of protection. Security equals products, tools, people, users, policies, rules. Example, you can buy the best firewall, but if your employee uses password 123, you're doomed. Now let's meet the bad guys. Every castle has invaders. Ours come in different flavors. Script kiddies, teenagers downloading free hacker tools, like toddlers with lightsabers. Dangerous but mostly to themselves. Hacktivists, political activists with keyboards. Example, defacing a government website to spread a message. State actors, government cyber armies. They're the James Bonds of hacking. Advanced, funded, patient. They use APTS, Advanced Persistent Threats. That means once they sneak in, they stay for years, slowly draining data. Insiders, the traitor inside the walls, could be a grumpy employee who sells company secrets. Cybercriminals, just after money, think ransomware gangs, competitors and terrorists. Yes, even businesses or extremist groups can play dirty attacks and weaknesses, vulnerabilities, platforms, old OS, Windows XP still running somewhere. Configurations, weak settings, open ports, default passwords. Third parties, vendors with weak security. Target Hack 2013 came via HVAC contractor. Patches, missing updates. Zero-day flaw discovered by hackers before a fix exists. Attack vectors, email, phishing, wireless intercepting signals, USB sticks, infected drives, social media, fake accounts, direct access, physical entry. Social engineering, humans are the weakest link. Hackers play mind games. Pretend to be the CEO, reset my password, urgent. Use humor, confidence, urgency. Tricks, phishing, vishing, smishing, dumpster diving, tailgating, shoulder surfing. Social engineering roleplay. One student plays hacker, tries to trick another into giving passwords. The class votes if they'd fall for it. TCP/IP, the Internet Post Office. Imagine every meme, email, and TikTok as a letter in an envelope. The Internet is basically one giant post office. And like the post office, we've got rules for sending mail. That's TCP/IP. TCP is like DHL, slow but reliable, package arrives, signed for. UDP is like tossing flyers out of a car window. Some reach people, others blow away, but it's fast. Now, how do we actually deliver this mail? With addresses and rules. That's where protocols come in. TCP, Transmission Control Protocol, reliable, connection-oriented, checks errors, guarantees order. Use cases, web browsing, HTTP/HTTPS, file transfers, FTP, SFTP, UDP, User Datagram Protocol, fast, connectionless, no guarantee. Use cases, Gaming, live streams, voice calls. Protocols and ports, like phone numbers. HTTP 80, HTTPS 443 equals websites. FTP 20/21 equals file transfers. SSH 22 equals secure login. DNS 53 equals converts names. Google.com 8.8.8.8. DHCP 67/68 equals hands out IPS. Message delivery. One group plays TCP, must confirm every note. Another plays UDP, throw notes without caring. Chaos ensues, lesson learned. Addressing cyber street addresses. Imagine the internet as a massive city. Every device, your laptop, your phone, even your smart fridge, is a house. To deliver pizza or data, you need an address. That's where IPS come in. But before that, every device has a MAC address, like its fingerprint, fixed at birth. Then comes the IP address, your house number. That one can change depending on where you are, Starbucks Wi-Fi versus home. Now here's the kicker. IPv4 is running out of addresses. It's like a small city with too few houses. That's why we created IPv6, a mega city where even your toaster can have Wi-Fi. IPv4 equals 32-bit addresses, 4.3 billion. Example, 192.168.1.1. IPv6 equals 128-bit addresses. Example, FE 80::1. Enough for every grain of sand. Types of addresses, unicast, one-to-one, broadcast to all, multicast, one-to-many, anycast, nearest server. DHCP equals hands out IPS automatically, like a hotel receptionist assigning rooms. Subnetting equals breaking networks into smaller parts, like splitting a big pizza into slices so everyone gets some. Give out candy as IP addresses, subdivide them, subnets, into groups based on colors. Students see how splitting makes sharing fair. Let's time travel through mobile networks. 1G, 80s brick phones, only voice, sounded like Darth Vader. 2G, texting, the age of WYD and ringtones. 3G, internet on phones. Hello, MySpace and early Facebook. 4G, streaming YouTube in class, pretending to take notes. 5G, boom. Super fast, super low latency. Self-driving cars, smart cities, VR concerts. 6G, not real yet, but people dream about holograms, instant brain-to-brain messages. Hey bro, did you just beam me a meme? 5G benefits. Speed, low latency, 1 millisecond. Massive IoT connectivity. 6G concepts. AI-driven networks, terahertz frequencies, ultra-reliable communication. SCIT. Students act out life in each generation. 1G user with brick, 2G texter, 3G Facebook addict, 4G streamer, 5G gamer. Networking in the cloud. Okay, let's clear this up. Cloud is not a magical sky computer. It's just someone else's computer you're renting. Public cloud equals Airbnb. You rent space, Google Drive. Private cloud equals your own mansion. More control, more cost. Hybrid cloud equals combo. Work in your mansion, party at the Airbnb. Tools in the cloud. VPN equals secret tunnel into the castle. Load balancer equals traffic cop. Make sure no server crashes. SDN equals Uber for networks. Software decides the best path for data. VPC, virtual private cloud. Your isolated corner in a public cloud. NAT gateway arrow hides internal IPS. Firewalls block attackers. Automation, IAC. Networks built by code, Terraform, Ansible. Fun demo game. Draw a mini cloud on the board. Students place sticky notes as servers, users, firewalls. Build Netflix's cloud together. Final project, secure my startup design network of a 10 PC business. Add firewalls, Wi-Fi security, access roles, IDS/IPS. Encrypt traffic, HTTPS. Create backup strategy. Present to class as Shark Tank pitch.